Welcome to the future.
In this video, we're going to be performing 17 tests on the Muxall IR Detector version 1 PCB that has the V2 mods. The results of this testing will be posted on the Muxall website for your reference, so it's not really necessary to watch this video if you're just interested in the results. However, if you want to see how specific tests were performed, then there are links to the different tests in this video's description. Okay, so 3.3 volts at 38 kilohertz. We're going to do max and minimum current draw. Minimum is 4 milliamps. Max is between 22 and 20, we'll call it 22 milliamps. Okay. Okay, so we're going to redo the test of max distance with no LED sleeve. The center frequency was not set at 38 kilohertz. I've adjusted the power to for max distance, and how you do that is you just turn the pot until the LED comes on, and you start turning the current down until right when the LED goes out. All right. So we take our super sophisticated distance measuring tool here. I'm saying looks like around 21, 22 inches. Okay, so I'm going to do the minimum distance with no LED sleeve, and I'm just going to turn this power pot down all the way down to minimum current draw, and our measurement tool here. And I'm about 3 inches, it looks like. All right. Okay, I'm going to install the LED sleeve. And this is just an LED mounting sleeve for, like, if you're going to put it in a piece of metal. I just use it to cover the LED, so it prevents the scattering into the IR sensor, right? Okay, so I just put that on there. Turn our power back on. Now with this, you can turn the LED power up, so I'm going to go ahead and increase the power. I'm just going to increase it until the spillover is detected into the reflector, into the sensor, I mean. And then just turn it down a little bit. All right. Get our test cardboard. Woo. Okay. Looks like about 25 inches, I think. All right. So 25 inches is the max. I'm going to turn this all the way down to the minimum power. All right. And about 2 inches, it looks like. All right. Okay, so I'm going to install an IRD infrared window. This is like something you'd see on one of those hand dryers or water faucets or anything, any kind of commercial type or even toy, I guess. Remote controls, that sort of thing. It's actually pretty thick. You can see it's, gosh, at least 1/8 of an inch thick maybe. So I'm going to go ahead and turn this off. Go ahead and put it on this guy. And what this thing is, it's got a couple holes cut out for the infrared LED and the infrared sensor. And this is what I use to test these boards for the Muxall movement clock. All right. Go ahead and install this guy back in here. All right, let's turn it back on. I have the power turned all the way down, so let's go ahead and test the minimum distance first. All right, looks like around, I'll call that 3 inches. All right, now I'm going to test the max distance. Just going to turn the power back up. All right, turn it up till the LED comes on, then turn it down just a tad till it goes off. I'm surprised that seems kind of low. Go ahead and readjust this pot. Yeah, I'm just. Oops. Oh. Yeah, see, that looks. It's a little too sensitive right there. Let's try that. Let's see how that works. Wow, it's detecting it. I don't remember having this much of a problem. Okay. We're getting a lot of scattering noise. I guess it's from me. Trying to hold this paper up. No, it's coming from the cardboard, but I don't know. We'll call that, I don't know, 26, 27 inches. You guys probably can't even see that on the camera. Anyway, it's way up there. Okay. Okay, so next on the list is frequency range. Go ahead and turn this off. Take this guy off. Put a probe on here. I'm just probing off of one of the leads from the infrared LED. Okay, so right now we're at 38.3 kilohertz. I believe that's all the way down. Oop, wrong one. Yeah, it's all the way down. If we turn it up, 59.8 kilohertz looks like it's about the max. All right, so minimum is 38.3, max is 59.8. Okay, so what we're going to do is we're going to adjust this thing for minimum distance. And it's a little different than maximum distance. Let me turn this all the way back to 38 kilohertz. Okay, so now we're at around 38.3 again. So, and please excuse the look of this square wave. I'm probing off one of the legs of the infrared LED. It's picking up all kinds of capacitance and noise, and it's ringing, and it's just pretty ugly looking. But we don't really care. We just want to look at the frequency and how you adjust. So right now, is this at minimum power? Okay, so I've got it at minimum power right now, and as you can see, so it's about 3 inches, right? And that's a little bit too far for minimum power. So what you want to do, for minimum distance, I'm sorry, not minimum power. So what you want to do, let's say you want to put this in like a Roomba type device that's sitting on the floor. This thing is only an inch off the ground, right? It needs to be really close. We want the least amount of distance that we can get. All right, and since I have the power turned all the way down, the only thing we can do is turn it off frequency. And the way you do this, you don't need an oscilloscope to do it. We're just doing it to mark the or to measure what frequency it's at. And I did this earlier, so I can have an idea. So I'm going to turn this frequency knob until I get to the minimum distance I'm looking for. And I don't know if you can see it right there. That's about an inch. Okay. Yeah, it's hard to see, but there you go. Maybe this will be better. There we go. I know we can't see the. Okay, so you can, we're probably about an inch still. Okay, so now it's not detecting anything. That's not good. Okay, there we go. So we got maybe a ½ inch, I don't know if you can see that. And we're at about 40, it says 41.8. We'll call it 42 kilohertz. So that's a minimum that you'll be able to do. But you have to turn the frequency off axis, or off the center frequency of the infrared sensor. Alright, so we'll just mark that at 42 kilohertz, that's close enough. And then what we're going to do, so that's at maybe a ½ inch. That's not even doing a ½ inch anymore. But you get the idea. I mean, you can turn this way off axis and won't detect anything. So let's go ahead and turn the power back up. Let's see what it did to our max distance at this off at 42 kilohertz, or 41.8. Whew. Oh, hold on. Let me get some spillover. Alright, just a spillover out. There we go. I don't know, looks around maybe 12, 13 inches. Okay. Okay, so we're still off center. off our center frequency. We're still at around 42 kilohertz. I'm going to install the sleeve on the LED. I'm going to power this guy back up. And let's see what his minimum distance is. Woo! He's a tad bit higher there. What do we got? I think about 5 inches, you think? So let me see, is that the power, is that the very minimum? Oh no, I didn't have the power at the very minimum. Oh, wow. Okay. Yeah, so with the sleeve on, it makes a big difference. So what's happened is I put the sleeve on, and I forgot in the last test I had this turned up to the max power. But with the sleeve, we're not getting the spillover. I forgot to turn the power back down, and now we're not getting any detection at all with the sleeve on. So I'm going to have to adjust this frequency again. Let's see here. I know this is kind of hard for everyone to see. There we go. So we got, around a ½ inch or so, maybe 1/4 inch. We'll call it a 1/4 inch. Because I can actually turn it down to where it doesn't detect at all. And yeah, let's check that frequency. Let me turn this off real quick. It really doesn't matter, you don't have to check the frequency, but I'm just kind of curious. Yeah, look at that. Talk about improper probing techniques, right? Alright, let's see what we got going on here. About 40 kilohertz. Alright. That's, I bent my detector, or the infrared receiver. Oh, that's not working at all again. Well, it's probably because, that's why I keep disconnecting this probe right here. It changes the results, right? So, it must be adding more capacitance or a little bit of power, I don't know. I've got it right on the center frequency and it's still, oh yeah. That's why I use this board, by the way, because my hand is not a really good test instrument. At least this is, it's white. It should reflect pretty much everything. It's long enough. I can match it up to the scale right here, or the ruler. Yeah, so anyway, we're going to call the minimum distance on this a 1/4 inch, because obviously I can turn it down to where it doesn't detect at all. So, well, I'm adjusting back down to 39.2 kilohertz because it wasn't detecting at 40 kilohertz anymore. And I think a lot of that is because of the way this detector, the sensor, it's got an automatic gain control, and you start messing with it long enough and it'll adjust itself. So, but the reason why I wanted to continue is I want to do the max distance on this real quick. So we're just going to turn the power back up on this guy. Let's see, we don't need this guy anymore. There we go. Yeah, see, I made a difference. Let's see. Alright, well, I have the power turned all the way up. Let's see. Okay, well that's not too bad. About 24 inches it looks like. Yeah. So that's good. That's off the center frequency. So it's about around 40 kilohertz, right? Okay, I'm just gonna put this IR window back on. Okay, we're still off the center frequency around 40 kilohertz. Adjust the power down until the LED goes out. Alright, and this will be the max distance. It looks like around 10, 11 inches, huh? That's different. That's a max. Okay, so let's turn this down, turn the power all the way down. Let's hit the minimum. Wow. Yeah, see, we're gonna have to turn it off axis again. Well, there you go. Call that around quarter or a half inch, something like that. Alright. I actually wasn't able to turn it, so it's still at 40 kilohertz. Alright. So for our next testing, we're going to be testing at 5 volts. And, well, let's just start from the top. I'm going to go ahead and pull this guy off. Set the pot all the way back down to 38 kilohertz. Plug in, turn it on. Okay, so for the first test, set it. Should be at 38 kilohertz. I guess we can double check that real quick. Yep, 38.4. It's got some noise in there. This is a really bad setup. Yeah, see how I cleaned up the noise, some of the noise just by. Yeah, this is horrible. Don't ever probe like this. But anyway, it's okay for what we're doing. Turn that off. That's just bad. Okay, yeah, so we're around 38.4 kilohertz, and we're going to do the max min power draw at 5 volts, or current draw I should say. Alright, so the max is 39 milliamps. The min is 6 milliamps, alright? Okay, for this test we're going to do we're going to do the minimum distance first. I have the power turned all the way down. We're at center frequency of 38 kilohertz, and let's see what our minimum distance is. Yeah, looks like about around 5 inches. All right. Okay, so let's crank the the current up on this guy. All right. Looks like around, I don't know, maybe 23, 24 inches. And we'll call it 23 inches, all right? All right, we're gonna go ahead and install this sleeve on this LED. And back on. I turned the power down. The power is down to minimum, and we'll see what the minimum distance is with the sleeve on. interesting. I don't know why it's different, but I don't know. We'll call that 4 inches maybe. So 4 inches is turning the power up on it. I expect this to be a lot higher. All right. Huh. Well, about the same. I'm kind of surprised. When I tested this earlier, it was much higher. I don't know. I've probably been bending these things around and messing it up. It's yeah, see, we're 21 milliounces. Oh yeah, there we go. Yeah. You can't see this, but my arm is at least a foot over the 24-inch mark right here. Yeah, that's what I expected. So yeah, we call that 36 inches or something, right? Okay. I'll go ahead and turn this guy off. I'm going to put the IR window back on him. Alright. And let's go ahead and power him back up. We'll do the max distance first, so I'm just going to adjust the power down until our LED goes out. Okay. Yeah, that's still pretty high. It's well above. I don't know. We'll call it 30 inches. All right, as a max. And let's see the min. I'll just go ahead and crank the power way down. This is probably going to be pretty high too. Yeah. Actually, when I was testing it earlier, it was higher than this. I'm surprised it's this low. Anyway, so we got 30 inches and then, I don't know, maybe 8. Yep, maybe 8 inches for the minimums. 30 inches max, 8 minimum. Alright. Pull this guy off. We're going to go ahead and test the frequency range. It'll be the same, right? But it's kind of interesting to look at. Get this guy out of the way. Alright. So right now we're at 38, which is the minimum. Yep, 38.3. We're going to wind the wick up to 60.2. Alright. Okay. Well, that was easy enough test. Alright. We're going to do some off-center frequency testing to get our minimums down at 5 volts. Let's see where we're at. Oh, well, it's not on. Alright. I'm going to go ahead and turn the power all the way down. Okay, power's down. I'm going to start turning the frequency up. And this is all you have to do. Just kind of just keep tinkering with it till you get it where you want. You don't need an oscilloscope for this. Alright, we'll call that good. It's about 1/4 to 1/2 inch. Alright. And, oh, let's turn the oscilloscope on. Where are we at? 46.5 kilohertz. Alright. That sounds pretty good. At about, let's say quarter to half inch, right? Okay, I'm going to go ahead and fire this off. Don't need him anymore. Disconnect him. Alright, let's see the max distance on this guy. So I'm going to go ahead and turn him back on. Adjust the power up. Alright. Now this is off the center frequency, so it should be lower. Yep, looks like around, 13, about 13 inches it looks like. Alright. Okay, go ahead and put the LED sleeve on there. Alright, turn it back on. Crank the power back up. Oh, power's maxed out. 37 milliamps, alright. That bought us a little bit. Oh, well, not really. I don't think it bought us anything. Huh. Anyway, well, we'll call that 13 inches. Okay. Alright, oh, minimum. Yeah, let's do the minimum. Oh. This should be about the same. Yeah, whenever you go off axis like this, off center frequency, you can tinker with it until you get it to where you want. I'm going to call it half inch. Alright? Okay, so I can go ahead and install the IRD window, or IR window. Paw prints all over it. Okay. Turn this guy on. Go ahead and I'm going to turn the power down all the way. Do that first. Yep. Okay, so yeah, he detects, I'd call that quarter to half an inch easy. Alright. Yep. Okay. Yeah, we'll call that, I don't know, 15 inches. Alright. Performance testing. To start the performance testing, we have a close-up of the two IRDs under test. There is a 1 centimeter wide piece of plastic being rotated at about 12 RPM. The Arduino board is on the left and the Raspberry Pi is on the right. As you can see, the blue LEDs on the IRDs are in perfect sync with the passing of the plastic stick. The LEDs on the RPi and Arduino are being lit by the example code that you can download from the Muxall GitHub repo. The links for that are also under the video. Now, I've sped up the plastic stick to about 500 RPM. Even though I'm recording this test at 60 frames per second, the H.264 video compression is making the plastic stick and blue LEDs appear to be out of sync and missing quite a few passes. As we slow down the video, you'll notice that the plastic stick and the blue LEDs are really in sync. Even the LEDs on the Arduino and RPi seem to be keeping up okay. I expected the Arduino to keep up without any problems, but I am surprised. the RPi is doing so well since Raspbian is not a real-time operating system. Well, that's it for this video. I hope it was helpful. If you liked the video, give it a big thumbs up. That helps. And hit the subscribe button. That really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching. I'll see you next time.